Welcome back to the Savage Sullivan Math website. Today we're going to take a look at simplifying radicals. So when we look at this, we see that 50 is what we call the radicand, just some vocab for you. So we're going to break it down just like you did in elementary school with factor trees. But now we're going to look at perfect square factors. So when we look at the number 50, we can think to ourselves, what are factors of 50? And the ones that a lot of you are thinking of automatically are 10 times 5, and hopefully also 25 times 2. Now there are different ways you can simplify radicals, and in this video you'll see two different ways. So we're going to focus on the way first that uses the perfect square factor. So when I look at this list, my eye goes to 25. And I like 25 because 25 is a perfect square. So when I break this down, I can break this down as radical 25 times radical 2. Because we know that radical 25 times radical 2 will get me radical 50. So when I look at this line, I'm going to ask myself, is there anything I can simplify? And if I did it correctly, then the piece that's on the left should simplify to be a whole number. What is the square root of 25? Well, we know the square root of 25 is 5. So that part is taken care of. And then I want to take a look at radical 2. When I think about radical 2 and I think about the radicand, the number 2, I want to ask myself the same thing I did with 50. Are there any factors of 2 that are perfect squares? And since 2 is a prime number, it makes it pretty easy because it's only 1 and 2. So we can't break it down any further. So since we can't, we're going to leave that radical 2 underneath the radical sign. But of course in algebra, we know that we don't need to put the little multiplication symbol. So just like we would with any variable, we write it as two terms stuck together like this. So the simplified version of radical 50 is 5 radical 2.
For the next example, we're going to look at radical 40. Just like when we did radical 50, we are going to look for numbers that we can multiply together to get the answer of 40. So if you look at 40, and maybe you're not quite sure what goes into 40, but you know a 2 goes into 40, you could break radical 40 up into radical 2 times radical 20. We are looking for prime numbers at the ends of our branches of this factor tree. So since 2 is prime, there's nothing else I can do to that branch. But in radical 20, I can break that down into radical 2 times radical 10. Again, 2 is prime, but 10 is not. So I can break radical 10 down into radical 2 times radical 5. All of the ends of my factor tree branches are prime now. So I'm just going to write them out so I can see them all real clearly. This is a nice safety net row. You can re-multiply this, and if you get 40, you know you factored it correctly. So 5 times 2 is 10, times 2 is 20, times 2 more is 40. So I know that I factored it correctly. At this point, I'm looking for pairs of numbers. So I've got a pair right here. Radical 2 times radical 2, that's the same thing as saying radical 2 squared. And we know that square roots and squares cancel out. So in this circle of radical 2 times radical 2, that answer just really simplifies down to the number 2. Don't forget, though, that we still have this radical 2 times radical 5. So for our final answer, since we don't have any more pairs of numbers that we can do pairs to squares and take them out of the square root, we are just going to multiply them together again. So we have 2 root 10 because 2 times 5 is 10. And that is your final answer. If you found this video helpful, please like and subscribe.